just going to continue with this cubic solver page, but add into it the Visual Basic functions that real bit of an extra, and if you don't want to do these, then I suggest you didn't, because it adds us some complications, but also useful to understand if you really want to look into doing some programming, or you enjoy programming. Okay, so this is where we are with the spreadsheet that we had. Either after looking through the video or looking at the lecture recording, we've used the secant method to calculate 3 values of y2 that we've identified of where they are on the chart, and I pointed out that, and it's underneath this this blocked out part, that if we highlight that cell, there's a function here called secant cubic that I wrote in Visual Basic for applications, which is within programming within Excel, and this would solve a cubic. Now, in actually just using this secant method for you, where you'd enter the values that are necessary. The second function is get the highest cubic depth. Well, this uses a heuristic way of trying to find the 3 solutions and find the highest one. Actually, it doesn't find the 3 solutions, it just starts at the high point and then counts backwards until it finds one. So you have to put the right data in to help it get to the solution. But at the moment these are clearly not working because they've got hash name question mark. That means the function doesn't exist. So we need to include the function into the VBA, into the Excel. So first thing you need to do is to download from Minerva the cubic sols.zip, and that's in the week 2 area. Now it's a zip file because inside it's got a Visual Basic script, so I'm going to just extract this, and I'll extract it into this same folder here that I'm in. And there it is. It's got a visual cubic sols.bas for basic Visual Basic. Okay, so we're going to include this function script into Excel. Let's go back to Excel. There we are. Now to do this we need to go to developer options. Now developer options might not be showing on your Excel, so we need to go to home options and try and find the place where we can customize ribbon. So customize ribbon, you need to click developer options. So it might not be clicked, but click it, so it's going to appear. So I don't need to do, I'm not going to change it, I'm going to cancel. So we select developer options and we go to Visual Basic. Now I generally don't do that. If I generally press Alt F11, which is shown here, Alt F11, and pressing that opens this screen. So it opens a separate window. Right, and if you've only got one Excel, I've got a few Excel things open here. And I have this specific energy calculations open. So we identify the one that you're working in, and within that we need to right click it and import file. I'll go to look for that, and here I actually go to the one I've just extracted. cubicsols.bas. I'll press open and it appears. Secant cubic here, that function that we've talked about. Get the highest cubic depth function again, and these are all stored under this modules, and it's labelled cubic sols. Okay, now we don't need to touch this again, this will work. You can go in and change things if you want, but I'm going to close that window. We're back in Excel, and what do we see at the top? Can't autosave. Visual Basic projects must be saved with a macro enables workbox to assume autosave. Save to macro enabled file type. So it's actually worse than this, because actually the file, even if you save it manually, you wouldn't be able to open it as a macro enabled workbook. So this function we've just included wouldn't work. So we need to save it now as a macro enabled workbook, and this is easy to do, but it changes the name. So it's changed. It was originally XLSX. We need to save it as a XLSM file. We can use the same name, but the extension needs to be XLSM. So I've now saved it. So if we were to just look in our folder where our files were, we can extend them, we can see that we've got two versions. Now you can use the XLSM from now on, or you can carry on using the XLS, but that won't have the function in. So that's a slight confusion. Right, so back to Excel. What do we do with this function? Well, we can see that cubic solver is now, whereas it used to say name, it now has a number in there, 0.5852. Actually, it's calculated that second one, and get the highest one is 0.9586. Well, it's not quite got the highest one, but it's not quite got exactly the same number. That's probably a tolerance thing. It's got the 9589. Okay, so it's got the highest, the one we're looking for, and that's accurate enough. Now let's just tell you how those can be used a bit more flexibly. What parameters do we need to put in? So let's just highlight the cell. We see that it uses the C4, C5, C6, C7, which are the ABCDs, so that defines the cubic that it's solving. Now the next value, well, I'm going to show you a trick where we can look at what it's got in there. If we do equals, and then we click up here on function, and we go to user defined, and we go down to find secant PQR, secant cubic, we can go, and it gives you some prompts, and it's got the ABCD prompt. Error, that's error is the next argument, the tolerance. Num is the number of iterations, and x0, x1 are what we used as our initial two guesses. So let me do that for this one I've just put in. Let's see, we'll put A for A. Oh, no, that's not right, is it? 1. That doesn't look right, it should be C. Why is it not coming up with C? Okay. C4. C5 for B, C6 for C, C7 for D, oh, C6, that's great that. The error, Well, we can put a number in here, or we can select it from a cell. Let's put a number in, 0.0001. I just need to scroll down a bit. How many iterations? Well, I've been doing 10. 10 seems about right. We could increase that, but let's not worry. Let's have a look at, well, the one that's showing, so x0, 0.4, 1.0. In fact, why not just choose those from the table? So I'm going to choose that L11, and I'm going to choose that L12. The norm and tolerance, norm and error are not going to change, so we can leave those in. Oh dear me, why has that not worked? It's because I chose L10 and not L11. See, I chose that Y and not L11. Okay, and it came as this table secant did, 2.995. Now I'm going to just change these numbers to try and get another one. Let's do the minus 0.5, 0.4. That came to 5.59. Now it is 0.585. You see, it's not quite as precise, and that may be because of this tolerance. Let's put an extra tolerance value in here, and there we have higher tolerance has got to this bottom solutions here. Okay. We can do a similar thing. Well, let's just demonstrate we can catch the 0.58. So if we did 0.4 to 0.5, yeah, there we have the 0.58 and 0.5. Oh, because they're both the same, it just comes up with an error, but let's put in 1 and it gets the 0.9586. Okay, let's have a look at the cubic, highest cubic. So I'm going to use this function value, click on the F, user defined, and I'm going to go down to get highest cubic depth, the one without the Excel filing, because that's another one I have open. So if we're clicking on that, we can see a little prompt here. We have ABCD, X low, X high, and that's going to be the full range we want to look over, and the number of intervals between X low and X high we're going to use. So let me just click on that. I can click on the A, the B. Why did I not get the right one? So it's C4, C5, C6, C7. Now X low, I can put them in here, but by hand. And the range here is between, well, in practice we only want 0, depths above 0, so I can put 0 in. And we don't know what the highest is in general, but right, so I can put 10 in here. And number of intervals. This is how many we split between 0 and 10 to start looking in each of those. So I'll put 10 in again. And we see it's given as a prompt of the solution 1.19, which is not correct. And why do I see that it's not correct? So I go looking at the function, and I've written in C6 twice. I need to put C7 for the last one, and that's come at -1. Let's just check that. No, that if it's -1, it's wrong. Turn in here. Let's get the range a bit more sensible. Okay, so the range I put in originally of 10 was too big, so I've changed it to be between 0 and 1. We could have had a bit bigger, I think, a 0 and I put it as 0 and 2, but I put 0 and 1 in there. Oops. We could have had that at 2, and it still gets the same solution. Tolerance is not as high in this. Okay, so there's a way of using those two functions. I think those are useful, but also add a bit of complication that's not necessary unless you really want to get into the programming. Okay, I'll finish that.